Welcome to chemistry. In this video, we're learning about the pH scale. And so if we look at the pH scale, as you can see here, this is a measure of how acidic or how basic different substances are. So for example, if we look at 7, this is what we consider a neutral pH. And so that would be distilled water. Pure water at 25 degrees Celsius has that pH of 7. It's neutral. And then if we look at things that are on the acidic side, 5 would be coffee. Lemon juice is somewhere around a 3. Coca-Cola, a little bit higher than 2 possibly. These are often things that people drink. And so often drinks and foods tend to be on the acidic side. And of course, on the very acidic side, we have actual concentrated acids. Here we have concentrated hydrochloric acid. It's actually less than 0. So notice that we can have pHs that are less than 0 and, as it turns out, greater than 14 as well. The pH scale is not bound by 0 or 14 as if they were artificial limits of some kind. Now, on the basic side, any pHs greater than 7 are considered basic. So we have baking soda and hand soap here in the 9 and 10 area, ammonia around 11, Clorox bleach, oven cleaner. Notice almost all of these things on the basic side of the pH scale tend to be cleaning products. And so anything from baking soda up to that, bleach, oven cleaner, I suppose the stronger you need something clean, the more basic you need it to be. So this is the pH scale, just generally speaking. Now, let's look at the mathematical definition of pH. pH is equal to the negative logarithm of the hydrogen ion concentration, H+. Now, there are some students taking chemistry who have not gotten far enough in their mathematics to know what a logarithm is. It's basically just an exponent. And so let me show you an easy way to figure out the negative logarithm of something. If you have a concentration where the hydrogen ion concentration is 1 times 10 to the negative first molar, that is moles per liter, well, the pH is just going to be 1. That number right there, 1. So the pH is exactly 1. Now, if we have an H plus concentration that's 1 times 10 to the negative second, then I imagine you can guess that the pH is going to be 2. And it is. Likewise, if the hydrogen ion concentration is 1 times 10 to the minus third molar, pH is going to be 3. So this is just a simple way to look at the negative logarithm. And hopefully you can find the logarithm button on your calculator, and you can calculate it pretty easily on your calculator as well. So if the H plus is 1 times 10 to the negative 11th, the pH is 11. If the hydrogen ion concentration is 1 times 10 to the negative 7th, that would be a pH of 7, as you can see. So we use that exponent there, the negative of the exponent, to be the pH. If we have an H plus, that it's 2.3 times 10 to the negative 6th, well, we can estimate that the pH is going to be somewhere around 6, but we want to be more precise than that. So on your calculator, you would type in negative log of 2.3 times 10 to the negative 6th, or e to the negative 6, however your calculator reads that, and you should get an answer of 5.64. So yeah, our estimate was pretty close. It was around 6, but we like to be as precise as we can. Now, if you're going in the other direction, if you're given the pH and you're asked to find the H plus concentration, then this is how you would do that. It's 10 to the negative pH is going to be the H plus. So if you have a pH of 1, for example, you know that your H plus will be 10 to the negative first power. And you can plug that into any scientific calculator and get that the answer is 0.1 molar, 0.1 moles per liter. If the pH is 3, well then the H plus is just going to be 10 to the negative 3 power, which is 0.001 moles per liter. If the pH is 9.58, then your H plus concentration is 10 to the negative 9.58 power, which is, when you plug that in, about 2.63 times 10 to the negative 10th moles per liter. If we have something that's very concentrated, very acidic, and the pH is negative 0.54, well, the H plus concentration would be 10 to the negative 0.54, or just 10 to the 0.54, and that is 3.47 moles per liter. So this is how we can find the H plus if we know the pH. Now, we're going to close by taking a look at strong acids. Now, if you have a strong acid, the H plus is equal to the concentration or the molarity of that acid. And that's because strong acids dissociate 100% all the way. So if you want to find the pH of 0.05 moles per liter hydrochloric acid, all you've got to do is take negative log of 0.05. And so the pH of that acid is about 1.30. If you have a solution of 0.003 molar nitric acid, just take the negative log of 0.003, and that's 2.52. Now on this one, you can probably do this one in your head. The pH of 1.0 times 10 to the negative fifth molar hydroiodic acid, just take negative log of 1 times 10 to the minus fifth. And I hope you all can see that that is just 5. How about the pH of 12 molar perchloric? You got to take the negative log of 12 on your calculator. So key that in. It's negative 1.08. So this is a very quick discussion of the pH scale. I hope you learned something about pH. Hope you're able to appreciate the pH scale and what common everyday materials are on what part of the pH scale. If you learned something from my video or you liked it, please give me a thumbs up. My name is Jeremy Krug, and I teach chemistry, and I put lots of chemistry tutorials and videos up here on YouTube. So hope you join me again where we can learn some more chemistry together.